All right, this video is for Learning Target 11. In Learning Target 11, we're going to explore infinite geometric series. So an example below here, we're not going to discuss the football part of it. We do that in class. We can skip that part. But an example of an infinite geometric series is 10 plus 5 plus 2.5, aka 5 halves, plus 1.25, aka 5 fourths, plus dot, 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 which just means it's going to continue that pattern forever. Now, the r in this situation, you're multiplying by a half. So the r is 1/2. If you continually multiply by 1/2, this series of numbers is going to get closer and closer and closer to one number, to 0. Think about the fractions. If 5 over 4 is multiplied by a half, it's going to be 5 over 8. Then 5 over 16, then 5 over blah, blah, blah. It's always going to be 5 over a bigger number, right? So while that number is going to get closer and closer and closer to 0, it's never going to get to 0. Thus, here's an example of a convergent series. All right, sorry I had to pause the video, but that was an example of a convergent series because it's converging on 0. You can always tell whether a series is convergent or not convergent, which is called divergent, just based on its r. So let's take an example of a divergent series. For example, that would be something like 3 plus 6 plus 12 plus 24 plus blah, blah, blah. It's divergent, the r is 2, because the numbers are just getting bigger and bigger and bigger. They're not getting closer or converging on any numbers. They're getting closer and closer to infinity. So anyways, that's an example of divergent, and again, its r was 2. So I made a number line here to help you see if the r is between -1 and 0. So if your r value is -1 is less than r, which is less than 1, then this is a convergent series. If your r value is equal to 1 or bigger, so r is greater than or equal to 1, then it is divergent. It's also true that if r is equal to -1 or smaller, so that would be r is less than or equal to -1, it's divergent. Now that is all summarized in this formula right here, but I've found that some people benefit from that number line and using it instead of the formula. But let's explore just for a second. The r of our convergent series was 1/2. So this formula says take the absolute value of r. Well, that would just be 1/2. And that is less than 1, so we're looking at convergent. Now, if it's convergent, according to the formula, we can find a sum using the formula a1 divided by 1 minus r. So back to our example up here, the sum of all these numbers, the sum would be 10 divided by 1 minus r, 1 minus 1/2, which is 10 divided by 1/2, or 20. Okay. The example we used for divergent had an r value 2. So if we take the absolute value of r, that would be 2, and it's bigger than or equal to 1, so it's divergent, no sum. So back up here, our example, that would be divergent, and it would not have a sum. All right. Now, for the sake of the video, I'm going to find the r values, show that work, the r value here, and decide convergent or divergent with you, but finding the sum and etc., I'm just going to show the answers. But let's just start. The first thing you need to know is what is the r in any infinite geometric series. All right, in number 1, it would be 63 divided by 21. In number 2, it would be 360 divided by 480. Always take a second term divided by the first. Take any term divided by the one in front. Take 0.01 and divide it by 0.1. In number 4, it'd be 1/6 divided by 1/2. And then in number 5, it brings up an interesting issue, which we'll deal with in a minute. Okay? We still do need to find r. It's staring at us. We'll talk about it in a second. But r equals, in number 1, it's a 3. In number 2, r is 3/4. And in number 3, r is 0.1. All right, so looking at the number line, If r is 3, it's divergent. So no sum. And number 2, r is 3/4, so that's going to fall somewhere in that area. So r is 3/4 is convergent. So it has a sum, and we'll need to find it. R is 0.1, so that's convergent. It's between -1 and 1. Feel free to pause the video, go back and look at that definition again, but 0.1 would fall on the number line between -1 and 1, so it's convergent, and it will have a sum. Number 4, let's see, 1/6 divided by 1/2 is 1/6 times 2/1, which is 1/3. So the R is 1/3, that's convergent. So it will have a sum. All right, now the formula, I'll remind you, for a convergent series to find its sum is first term divided by 1 minus r. So number 1, we already found it, no sum. Number 2, it's convergent, so use the formula, 480 divided by 1 minus 3/4. Again, I will show that answer on another page. In number 3, the formula would say take your first term 0.1 and divide it by 1 minus r, which is coincidentally also 0.1. I'd like to do this one real quick because it's kind of neat. 1 minus 0.1 gives you 0.9, so that becomes 1/9. And what's kind of neat about that is the fraction 1/9 is the decimal 0.11111 repeating. So if we think about that, 0.1 repeating, what do you get when you add 0.1 to 0.01? You get 0.11. What if you add 0.001 to that? Well, then you're going to put another 1 there, and so forth and so forth and so forth. So that kind of confirms that if you added those decimals over and over and over again, you'd get the fraction 1/9. Anyway, it's kind of a neat little tidbit. And then number 4, the first term's 1/2, and we would divide that by 1 minus r, which is 1/3, and get 1/2 over 2/3, and so forth. So those answers go ahead and get that pulling up in the background while we finish number 5. We'll get to those actual sums in just a moment. Here they are. Not, hang on one sec. There we go. All right, so the answer to number 2 was 1920. The answer to number 4 was 3/4. The answer was 3/4, and you can see that work there. All right, but now let's talk about 5 and 6. I'll gently remind you that the formula for a geometric series is a sub 1 times r to the n minus 1. What we have here is a formula that looks a lot like the geometric formula. In fact, that 3 represents the first term, and the -1/5 represents r. The infinity symbol on top of the sigma is telling us to add the first to the infinity term of this geometric series. Basically, we're looking at a learning target 11, an infinite geometric series with an r value of -1/5. So as soon as we know that that r is -1/5, we use that same number line to say, okay, -1/5, that would be in that area, so it is convergent. And the formula would say take your first term, which is 3, and divide it by 1 minus r. Be careful, r is negative, so we're going to subtract a negative r, which becomes 1 plus 1/5, which is 3 over 6/5, which becomes 15 over 6, or 5 over 2. Fractions give you trouble. Remember, you got the calculator that we can use to help that out. But we'll do that more in class. Number 6, I used number 6 here to illustrate a point that happens every now and then. This is k equals 1 to infinity that we're adding, so another infinite series. The 4 over 3, parentheses 5 over 4 to the k minus 1 looks a lot like that formula again. So your first term is 4 over 3, and your r is 5 over 4. And I picked this problem to illustrate that just because r is a fraction, 5 over 4, doesn't always make it convergent, because this decimal is 1.25. And if you look up here at the number line, 1.25, we're going to be in the divergent area. The numbers are going to be getting bigger and bigger as you progress, not getting closer to any number or converging. So divergent, no sum. And I know that was very fast for Learning Target 11. I'll put back the other answers because there may be a little bit of more work shown for those problems here and there. But if you need help, feel free to come in for tutoring. Learning Target 11, that's going to do it.